Welcome to The Explainer. Today, we're going on a journey, tracing a line from simple, neat little tables all the way to what is essentially the long-term memory for AI. We're going to uncover the hidden story of how we taught machines not just to store our data, but to actually understand it.
So we've all been there, right? You ask an AI a question, and it just gets it wrong. Or even weirder, it hallucinates. It just makes up an answer that sounds totally convincing, but is completely false. Well, the root of that problem, believe it or not, all comes down to its memory. You see, our memory is flexible. It builds on itself. It gets context. But a standard AI, its memory is kind of like a goldfish. It has this very short, limited window, and once you move past that, it basically forgets the entire conversation ever happened. And that is the huge problem that needed to be solved.
Now, to really get the incredible solution that gives AI a memory, we have to take a trip back in time, way back, to the invention that first brought any kind of order to the absolute chaos of digital information.
It all kicked off with this game-changing idea from an IBM scientist named Edgar Cott. He came up with a system of cross-linked tables that could store any piece of data just one time, creating what we now call a single source of truth.
So here's how it works. Just imagine a perfectly organized table of all your users. Every single person gets their own unique ID, their name, location, and the really important part is each person gets only one entry, super clean.
Okay, so now you've got another table just for orders. It's a list of every single transaction. But notice that last column there? User ID? That little number is the secret sauce. It's the key that connects everything.
And this is where the magic happens. A special command called a join uses that user ID to link the two tables together. And just like that, you can ask really complex questions like, hey, show me every order placed by user 101. It was genius.
And for decades, this system was pretty much perfect. But then, the world changed. The internet happened. Mobile phones happened. And those beautiful, clean, orderly tables, well, they started to crack under the pressure of all this new, wild data.
All of a sudden, we were hit by a tidal wave of messy, unstructured data. We're talking photos, videos, social media posts, the whole shebang. And you just can't force a cat video into the neat little rows and columns of the old system. It just doesn't fit.
So, database technology had to evolve, and it had to do it fast. This kicked off a rapid-fire series of innovations. First came flexible NoSQL databases, then mobile databases for our phones, and finally, the tech that brings us right back to our original problem, vector databases built from the ground up to power modern AI.
And this brings us full circle, right back to AI, because it faces the ultimate data challenge. It doesn't just need to store words or pixels, it needs to somehow understand the meaning behind them all.
The big breakthrough here is a concept called vector embeddings. Now, it sounds complicated, but the core idea is pretty cool. You take any piece of data, text, an image, you name it, and you translate its meaning into a mathematical format. It's like turning a concept into a set of coordinates on a giant map.
The source material really nails it here, saying this is what's critical for AI to gain understanding and maintain long-term memory. This is the missing link, the bridge between just having raw data and actually having comprehension.
So, as you can imagine, this required a totally new kind of database. The old relational databases, they search for exact matches, but vector databases, they do something called a similarity search. They find what's closest in meaning, not just what's identical in the text.
And this is the perfect way to think about it. In that giant conceptual map, the ideas of joyful puppy and happy dog are plotted right next to each other. They're neighbors. But sad cat, that's way over on the other side of the map. It's a database that's literally organized by relationships and meaning.
Okay, so this technology is amazing. But how do we actually use this new AI memory to build a chatbot that's not only smarter, but one that we can actually trust?
Right. The main challenge is still there. How do we stop the AI from just making stuff up? Well, the answer is a really powerful technique that basically connects the AI directly to a trusted library of facts.
And this process is called Retrieval-Augmented Generation, or RAG for short. At its core, RAG gives the AI a dedicated knowledge base that it has to check before it even tries to answer your question.
It all works in 4 pretty simple steps.
First, you load up a knowledge base with trusted data. When you ask a question, the system instantly finds the most relevant facts from that base. Then, and this is the clever part, it combines your question and those facts into a new, smarter prompt. And only then does the AI generate an answer based on the facts it was just given.
So the way to think about it is that RAG gives the AI a factual cheat sheet for every single question. It grounds the AI's amazing language skills in a verifiable source of truth, and that dramatically reduces the chance of it hallucinating.
So when you zoom out and look at the whole story, you realize this isn't just about one little innovation. It's been an entire journey.
I mean, think about it. What started as a way to organize things like airline reservations has now become the fundamental building block for a whole new era of intelligence. We're talking about systems that can finally grasp meaning and context.
This entire evolution, spanning more than 50 years, from Edgar Codd's paper all the way to today, was the necessary foundation. Without this half-century of hard work, the AI tools we see popping up everywhere now simply would not be possible.
This really is a profound shift, and it leaves us with one last, really exciting question to ponder. What happens next when the systems that hold all our information don't just store it, but actually begin to understand it?